Hello, my name is Ryan Yarbrough. I'm a PhD student in nanoscience at the University of North Carolina at Greensboro, and I'm the entrepreneurial lead for team number 16 in the NSF I-Core program for the JSNN Thermoelectric Group. My PI and academic lead is Dr. Hamali Rathnaki. So my research works on thermoelectric generators, and those are solid-state devices that convert heat directly into electricity with no moving parts. They're currently only used in very niche industries, where reliability of hardware is far more important than the cost of the hardware. So they have been used in power generation systems that the Air Force uses. They've also been used for powering rovers on Mars. The problem with thermoelectric generators currently is that they are very inefficient and expensive, and the aim of my research is to fix this by creating new materials. So through participation in the NSF I-Core program, we were looking to see what potential markets would exist if a generator with a high return on investment could be developed. And the starting hypothesis was that specific industries that are very energy intensive would be looking for ways to reduce the amount of energy consumed and therefore reduce the operating costs in that industry. So through the program, I've interviewed CEOs of trucking dealerships, heads of North Carolina environmental agencies, and power plant managers, among others. Through this process, what I've learned is that almost every industry and field contains at least some potential customers. And each industry has its own incentive structure for why they would want to do this. And most of them, though, are purely economic market forces. A great example of this is trucking. So while the EPA has regulations regarding engine efficiencies and emissions, just a small improvement in the fuel economy of trucks would be enough for companies or individuals to make the investments without regulatory pressures. There's also the U.S. Green Building Council. It's the nonprofit that handles LEED certifications to try to push buildings to be more energy efficient and environmentally friendly. And incentives for those are wide-ranging, including tax advantages and also just saving money by improving the overall energy efficiency of your buildings. And from talking to people, the efficiencies of these buildings can be further bolstered by utilizing the waste heat produced from hot water and heat pumps in these buildings. So power utility companies are a full mixture of economic and regulation incentives. So regulatory pressure does currently exist in North Carolina, where utilities by 2021 have to increase the efficiency of their power production according to the North Carolina Utilities Commission. While they are always looking to keep the efficiency of their power plants at their peak, they are always trying to make it better in order to comply with these regulations. So from the interviews, the value proposition becomes very clear. Customers want to save money, and that can be done by recovering waste heat. Thermoelectrics with a high return on investment can directly improve the bottom line profits of these companies and help companies also comply with regulations. So with the knowledge gained from this customer discovery, it appears that several markets could exist with an advancement in this technology.